So this talk is about future data platforms and PaaS services. I guess a little bit of detail, I've been dealing with platform as a service since my time at Foundry, which was pre the original launch when it was part of VMware. I then went and spent roughly just shy of 2 years at Warner Music Group, implementing a customized version of Foundry in the enterprise, dealing with all sorts of interesting challenges, including quite a bit around data. And I left just a few months ago and joined Basho as the CTO. Basho is one of the NoSQL storage companies. They make a product called React, which is key value storage, and another product called React CS, which is object storage built on top of that. That's probably the last you'll hear me talk about Basho or React, except maybe a bullet or something. So you don't have to worry about this being a long, boring advertisement. Hopefully it won't be long and boring at all, but at least you won't have to hear more about Basho right now. So what is a data platform? This is kind of my definition. I didn't take this definition from anywhere. I just sat down and wrote it. You can see a technology or collection of technologies that can provide the majority of data services required by developers and needed by enterprises for data, and especially PaaS. If you've dealt with platform as a service in any type of enterprise environment, you'll find that data ends up becoming a very interesting challenge. You're reliant on a set of abstractions that are giving you access to data. You may be dealing with handoffs. You may be dealing with relational databases, non-relational. But what you will find is there's a lot of complexity around data, especially as your needs grow and as your applications grow. You will want to do all sorts of things with the data, and that's really a large portion of what this talk will be about. The other side are what are PaaS services. These are some examples. These apply to all the PaaSs I'm aware of that are out there in one form or fashion or another. Some of them may not have one capability or something on them. Others may have all of these. I think the point is that these are examples. You'll see that I've highlighted storage because that's what we're going to focus on. Arguably, messaging can be a form of storage, and you can have extensions to search that are storage. You can have processing that occurs that both feeds out of storage and then feeds back into it, and logging and audit actually have to rely on storage in one way or another. Bit of a disclaimer. As I get later on into the talk, I'll be doing a little bit of fortune telling the future. This is based purely on my experience and things that I've seen, and obviously no one can truly predict the future. Certainly if I could, I wouldn't be here right now. I would be wealthy, probably on an island or something else at this point. Hope you're hungry. Many of my slides, in fact the majority of them, will have pictures of food on them, so be prepared for that. I wanted to make this talk at least visually interesting as well, so I chose food as my comparison. So storage comes in many forms, depends on how you like your storage. There's both raw and cooked. Raw might be block storage or file systems or some other very low-level thing. And there are different platforms that can expose different levels of raw storage to you. And depending on your purposes, it may be perfectly acceptable to leverage these types of constructs. At the same time, at least in many enterprises, and especially in PaaS, people are looking more at cooked things. Arguably, some of these might be more rare or medium rare than others, depending on which project or solution we talk about. Many of these, in my experience, are being used today in platform as a service to one degree or another. Some of them are more popular than others, and these offer different capabilities. The interesting thing is there are, at least the majority of PaaS implementations that I've seen are using many of these. In some cases, you'll run across enterprise platforms that are using all of these in one place or another, as well as many more. This has advantages in that each of these is designed to have a set of strengths and weaknesses in platforms, as do all of these. An example, Elasticsearch is fantastic with being able to ingest data and do all sorts of really interesting things. It was the first to have clustering in the search category. Cassandra has a good scalability story these days. It has lots of capabilities around being able to do materialized views, and it's evolved over time. Mongo is super easy to get started on. Arguably, you can have it up and running in minutes, and at least from the developer side, very easy to store data and pull data, and it uses a document-oriented paradigm, so everything looks like a document in Mongo. React's a key value store, so pretty simple concept. You store keys and values, you request a key and you can get a value, or you can say, I want to store data in this key, and the data you store is a value. Pretty easy concept to get. Solr is another search technology. It's the oldest of the search technologies that are open source and in use between Elasticsearch and Cassandra. There's people using Solr and Elasticsearch at the same time, or some people will favor one over the other. Solr's strength is in its maturity. It now has clustering. It got it after Elasticsearch, so it has lots of capabilities there. And finally, Redis is an in-memory key value store. Lots and lots of people using Redis in the enterprise. Very high performance, incredible response times. The downside is it doesn't have a good availability story right now. You can't cluster Redis, at least very easily. So again, people are picking combinations of these things because there is no magic bullet that can solve all of their data needs problems, at least in this NoSQL space. There are classic relational stores that have lots of maturity in them. They have other limitations. So none of these things are just, oh, you can put everything in here. It's a one-size-fits-all. There is no one-size-fits-all, at least not today. And so talking a little bit about the different types, these are all different types of ways you can store your data outside of classic relational databases. So you've got key value, that's the KV, object, document, graph, time series, queue, columnar, table, cache, and there are a whole host of more exotics and other populars that are on this list of ways that you can actually store your data. All of these constructs are here for a reason. They're not just because developers like more and more constructs. They're to solve different types of problems and to handle data in different ways. Data that you might store in a graph might be very rapidly changing and very difficult to put into a schema specifically. Graphs are really good at handling some very complex problems. There's a lot of difficulty if you wanted to use a graph for time series. It's possible. I've actually seen someone give an example of how they were able to store time series in a graph. But overall, you would be better off storing that in something that's designed to store time series data. Time series data could be log data, it could be event data, it could be Internet of Things data. So you could have sensors distributed all over, and they're each reporting every 30 seconds an aggregate amount of information. Maybe it's temperature and humidity and pressure and several other things. Reporting them, all of that is time series-based data. So it would be better if you had a storage solution designed to handle that specific use case. So we have time series as a construct. Queues are a different form of storage. So all of these are types of storage. They all are here to solve problems. It's just what level of problem, how mature is the solution providing this to you? What are the capabilities versus your needs? In the world of PaaS, you have ready-made services and made-to-order services. And I'll explain a little bit about, at least in my mind, what the differences are. Ready-made is kind of like a TV dinner. You just get it out, you cook it, and you eat it. And there's really not a lot of other work involved. And baked into PaaS, you'll see all sorts of different services out there. These services have already been set up, they've already been tuned and configured in a generic way, and you can just begin to consume them. So very, very low barrier to entry to begin consuming these services. which is great. Again, there's still going to be general purpose. So the more outside of that general purpose use case you have, the more specific, say, latency or performance demands you have, the less likely these are going to be able to meet your needs, at least today with the maturity state of services in the PaaS market. What's interesting is when you move more towards, say, made to order, where you spin up services on demand, these could be more customized towards what you're looking for to solve your specific use case. They do incur some more specific operations, and you will have to manage those likely yourself and maintain them. You may have to build your own gateway depending on how exotic you decide to go, at least this is from what I've seen. It's very, very powerful to be able to do this. Effectively, I'm seeing more and more companies that are trying to automate this as much as possible, and they're having some success, but there's no easy way to address all of these scenarios yet in PaaS, at least not that I've seen. In a perfect world, you'd have a gourmet kitchen with a personal chef. I don't have this, but I would certainly like to. It's a team of people that can create the services you need, customize them, automate them. The operations and maintenance is still based on these individual services. So each service is different, and something that few people are yet talking about are the different SLAs that services may need. So you may have multiple services that appear the same. Let's use Cassandra as an example. Cassandra allows you to have replication, and you can store multiple copies of your data with Cassandra, which is fantastic. The question is, how many copies of your data do you need? Well, you might have one use case where it says, no matter what, you can't lose my data always needs to be available to me, and so the decision's made to keep 6 copies of the data. And oh, by the way, it's so important, I also want you to take backups of that data. So if you think about it, that means that for all the data you're storing, you need 6 times the amount of storage, so it's a 6 times multiplier for each bit of information you're saving, along with however much space your backup takes. That can get expensive, but there might be legitimate business need to have that. So that would be a requirement of providing a much higher service level than what might be needed under ordinary circumstances. You might have another copy of Cassandra running, and that version, you know what, it might not be so important that the data be available under any and all circumstances, no matter what. It might be acceptable to have 2 or 3 copies of your data. And maybe you don't even need backups. Maybe it's safe enough that you're keeping 2 copies locally and 1 copy at a remote site. That might be perfectly acceptable. Well, now your cost is for 3 times the amount of storage you were originally consuming. So your costs are lower. Your service level's different though, and really all I'm providing to the business and to the developer is Cassandra. But they have different ways you configure them. They have different ways that you might choose to operate them. They might have different numbers of machines involved, and they have different amounts of storage, but I'm still just talking about Cassandra. We don't hear a lot about that today, but that's something that's going to be occurring more and more and more as enterprises adopt platform as a service. So the kitchen of today is individual storage services. So these are examples like the Cassandra, the Redis, the Mongos, and such. They have separate maintenance. So each of these things has to be maintained independently. You're providing maintenance different to how you treat Redis than you do Cassandra, or than you do Mongo, or than you do any of the others, Elasticsearch. It's because of this that then you have to separate management. So you have separate management, and that management has to be treated differently. You can't treat all of these things the same because they were built by different people, they operate different ways, they're configured different ways. It gets difficult. You're also trying to transfer data between these stores, which is something else that a lot of people aren't yet really talking much about. And that is, I've stored my data in Mongo, but I need my data indexed in Elasticsearch, and I also want to keep a copy in Redis for in-memory operation. So how do you put the data into all of those, and how do you keep the data coordinated and synchronized, and what do you do with this? That's a difficult problem, but it's a problem that really hasn't been addressed all that well today. The way I've seen people address it so far is for them to engineer their own solution inside of their platform. So again, much more complicated. As well as by doing this, you end up with separate silos of expertise. Generally, you don't have, say, one guy or even a few guys that are operating this data inside of the platform by themselves. So you don't have one guy that's your expert on Cassandra, Mongo, Redis, Elasticsearch. If you do, then he's one heck of a guy to be an expert with all of these. And so your expenses go up because now you're trying to hire all of these different people with all of these different specialties. And by the way, what happens when one of the guys gets sick or something else, and now your Cassandra guy got sick and he was your only Cassandra expert and you're having a problem. Now you're either trying to go to the vendor or you're stuck. Or you have somebody that maybe knows a little bit about Cassandra that's going and trying to futz with it, trying to figure out what exactly the problem is. So it gets difficult. And finally, orchestrating all of this gets really, really complex because you're trying to deal with all of these issues. They're not simple issues. They can be managed, but it requires a team of people. And it becomes really difficult when you have knowledge walk out and you're kind of sitting there going, all right, now how are we going to coordinate all of this? It also becomes complex in trying to deal with the processes to wrap around this so that you don't have people building what I'll call errant services. An errant service would be Bob decides that he doesn't like the services that are provided today and he happens to have access to the infrastructure and decides to spin up MongoDB. And he starts writing an application to leverage MongoDB, and you have no expertise in MongoDB. And you don't know how to operationalize it, and you don't know how to manage it. And what do you do now that he's written an application that uses Mongo and you find out that you now have MongoDB in your enterprise? How do you either operationalize it, or how do you get the data out of Mongo and move it to one of the things that you have operationalized? These are really complicated problems, and they get very expensive and time-consuming. And this has already happened, and I think it will get worse before it gets better. So what does the kitchen of tomorrow look like? I see it as having unified storage or something close to it where you're able to treat the majority of your storage the same. You might have special cases of storage. You might have split out, say, some storage that you use specifically for relational. I think relational storage for related relational database, I think that's probably a 15% of all your applications really, really need a relational database. The rest could use other specialized things that would better serve them, but you're still going to need that relational database for a specific set of problems. It wasn't just created out of the blue. There are legitimate reasons. I would apply the same thing for Hadoop, which is something I haven't really talked about, which is also in this. So there's a set of use cases that Hadoop is really good for in HDFS, and so I see that as kind of a separate area. And then there's this mix of other NoSQL solutions, and I see all of the NoSQL solutions being able to be stored in a place. So even if we broke it down in that way, you probably have 3 different things that you're storing data in. 3 is still a manageable number. It's not insanity like it is today, where you could have an enterprise that has 17 different or more different storage places. Sure, I'll take a question now. So the question was, is there a tree or a flowchart or something that will effectively guide developers to a specific answer or a specific set of selections based on what they're trying to do? I haven't seen that, but I think that's really one of the points of PaaS is to begin becoming more prescriptive for developers so that you don't end up with the problems we're seeing, and for you to be able to consolidate inside of your infrastructure all of these different things. I think we're still just really early right now in this, and that's why there's a little bit of fortune telling involved in this. I really don't know how it all ends. This is where we get into me making predictions that probably will be mostly wrong. I hope not, but they certainly could be. The idea is that you want few vendors. In a perfect world, it would be one, and you just buy this thing, or you get this thing in open source and you deploy it, and you can just store everything in it. We tried that with relational databases, by the way, and it didn't quite work out the way I think we all hoped it would. There are just too many edge cases that don't work, or don't work well enough to satisfy the business needs. So what we end up with is what we have today. I see tight integration. So I see tight integration in the different storage solutions over time. So people are going to demand that you're able to have a better integration between Elasticsearch and Mongo and Cassandra and Redis and all of these things. People need this, and they're going to continue to need this. This is simply something that doesn't take a lot of forethought, because it's becoming a requirement rapidly in anyone that's trying to adopt these technologies. So data works together between types. This means that key value becomes something that can be consumed by document, that becomes something that can be consumed by search, that becomes something that can be consumed by graph. All of these things should be consumable across one another. This is something that doesn't exist today. You could try and do something where you create a common format. JSON is certainly the closest thing we have, but interoperability, schema requirements and such destroy this today. There's just no viable way to do it. So you'd have to write some type of services or bridging tools or something else that would kind of copy the data or synchronize it across or something. It's just not quite the ideal way for things to work. Kitchen of tomorrow would be highly automated. So being able to add nodes for storing all of this cool stuff and doing things, you should be able to just add nodes as required without a lot of work. It should have that elastic capability. And you should be able to remove nodes too. Today, that doesn't really work as well as I think anybody would like it to. Things will break, especially if you try to remove nodes. But even adding nodes is not something that you can just drop down, turn on, and hey, look, I have another node. I have this additional storage made available to me. It just doesn't work that way. I think we're marching towards that. I think we will get there. We're not there yet. And ideally, you'd have a single expertise needed. You wouldn't have this siloing of all of these different capabilities. You wouldn't need an expert in each of these. We'd be kind of back to that, I have a DBA, and he manages my relational database, and he gets it, and I don't need 8 other DBAs unless I'm running 8 other types of databases. If I'm running Oracle, MySQL, Postgres, DB2, SQL Server, then I needed potentially several people that were experts. And I might even have a couple that were capable of being an expert across those, but your number of and amount of expertise is lowered. So if we go to a bit more speculation, I think really where this goes is you have some vendors that attempt to provide more of a unified solution, potentially building on what they have to offer a lot of the different constructs that are available. So that means I have one solution, and it's able to provide to me graph, document, key value, object, search. It gives me all of those things, and it's one solution. Open source or not, most of the solutions that I listed there, in fact, I believe all of them are open source projects as well, so I'll point that out. But that's where it needs to head. It needs to head to where I get all of these things from one thing, and I just pick whatever is best for me. And this flexibility, these capabilities that I get, give me much easier control. It gives me a degree of homogeneity in the fact that I'm getting it all from one thing, whatever that thing is. If I'm able to get all of that from that one thing, probably solves 80% of my storage needs as far as in the NoSQL space. It's not, again, a magic bullet. It's not going to solve every single problem. And if I find a specific deep enough use case, I may not be able to use it for that. But if I could even get 80% of the way there, that would be huge compared to where we are today, where each solution, I see people trying to shoehorn in, oh, we've done all these customizations so that we could do these 3 extra things with whatever, Elasticsearch, Solr, you name it. And now they have something that's even more specialized. It's custom to them. They have to manage it and maintain it because they've now customized it. And they've customized it because they were trying to use the screwdriver as a hammer. And if they would have just gotten a hammer, they wouldn't have had to change anything. So right now, there's no viable way to deal with either side. I see this as something that's the market's going to demand, and it's going to be how do we get there and how quickly we get there that's really more of the question. Again, this is my speculation. With that, I'm going to take questions for, I guess, about 3 minutes. That's all I have left, and then we'll end. So does anyone have questions? I believe that there are viable paths that many of the players could take to provide things like this. I think that all of them, Basho included, will take different routes, and the question will be, what are the viable routes that come out of that people can use? I think a few of them will become viable, and I think you'll find some that just fundamentally end up being broken in trying to address that type of a solution. But I wouldn't say Basho is or could be the only one. Sure. So the question is around APIs being layered over heterogeneity or heterogeneous-based data storage, specifically databases and such. So what that means is I have 3 or 4 different solutions, or maybe even 2, and I write this API to try and abstract away or hide what those really are beneath it. So for a developer, I'm exposing this API, and they just worry about talking to that, and they don't know what's happening under the covers with how I'm storing the data or messing with it or moving things around. It's a good way of buying time if you think that you're going to switch things out from underneath. It does give you more flexibility. You're right that you pay a penalty in that now you will break things if you need to change that API, and developers have written things against it. I think it's interesting because if you're providing an API that's supposed to be a compatible API with somebody else, an example might be S3. So S3 is Amazon's object storage. So a lot of people are writing APIs that provide compatibility. So if you had written an application to talk to Amazon's S3, now you could instead point the application to something else, and it still talks S3. So the application doesn't think anything has changed, but you've really changed the storage from underneath it. This is a powerful thing, but if the developer keeps marching to S3 and S3 keeps changing, then you now have another maintenance point in that you now need to manage the API, keep it updated, and keep it up to date to mirror whatever it is that's being written. It does have benefits in that you do get this flexibility. You can add new features and capabilities. You can swap things from underneath because of that abstraction. But the penalty is you now have something else that you need to manage and maintain because you've introduced this layer of indirection. So the question's around the trend of hardware that processing and memory is becoming less expensive, and that you simply store the data and then pick it up and change it as necessary, and then either store it back or present it to the application based on its needs. I think that it is possible, but you're also adding complexity, at least up front, and you then have to make up for that by creating logic to unwind the complexity. I think it's appropriate depending on what you're trying to do. If we're talking about sensor data, so massive amounts of data that's constantly flowing in from points, it might make sense to store the data like that. If I'm trying to write an application to solve a specific business problem, where I place the logic really depends on what problem I'm trying to solve. I think it gets back to what data format is the data coming in and what problem am I trying to solve with it that would determine what the best way to handle the data is. I think there's a class of problems in data that would fall under exactly what you're saying. It would be fantastic if we had an automated platform that could just ingest everything and you could get the ideal format you want out simply by requesting it. We may get there. I don't know how far out that is, though. I mean, that might be quite a ways out before we get there. Or maybe I'm wrong. It might be around the corner. So I don't really know. I know that for developers to be able to easily write code to it, they need to be able to wrap their heads around how the data is and how they need to deal with the data. And that's probably the biggest barrier to any of these things. And it's why they make different choices. I think it could. I think there's lots of storage technologies and people researching things around doing this idea. If you look at SSDs replacing spinning disks and you get a 10 to 100x in performance improvement. If we come out with a way of making memory persistent, like the violin memory stuff that I've seen, or mem resistors or something like that, could. We're probably another 10 years away, but I think we could see something like that, and it would change the game. It definitely would, which is probably what the next generation past NoSQL will be. With that, I thank everyone very much. Thank you.